Hello everyone, today we will find the raw moment of chi-square distribution. After finding this raw moment, we will also derive mean and variance from it. Okay, uh, so for raw moment, we know that it's denoted like mu r prime, defined as expectation of that variate of this distribution, like here chi-square and to the power r, and that is it how it's defined, as it is a continuous distribution, a chi-square distribution, so we will use integration from minus infinity to plus infinity. So here the variate chi-square to the power r, and its function will be f of chi-square d chi-square. Okay, fair enough, and we can extract it minus infinity to 0 chi-square to the power r, f of chi-square d chi-square, and plus 0 to infinity chi-square to the power r, f of chi-square d chi-square. Okay, and this part will create a value 0. I'm not showing you here, but if you calculate this part, it will be 0, so we will live with this one. It is 0 to infinity chi-square to the power r, f of chi-square d chi-square. Okay, now 0 to infinity chi-square to the power r, if you extract this PDF, what you will find, 1 by 2 to the power n by 2 n by 2 e to the power minus chi-square by 2 chi-square n by 2 minus 1 d chi-square. So that's it, and as you can see, this is a constant part, so it can be outside of this integration. So we can write it like this: 1 by 2 n by 2 n by 2 gamma n by 2, and 0 to infinity chi-square to the power r e to the power minus chi-square by 2 chi-square n by 2 minus 1 d chi-square. Okay, we found it. Again, next, and what we can do, okay, so you can see here there's a 2 chi-square, so we can add up them: 2 n by 2 n by 2, 0 to infinity, okay, e to the power minus chi-square by 2 chi-square, and it will be n by 2 plus r minus 1 d chi-square. Okay, and now this integration is pretty much difficult for us. For this complex integration, we trying to do it more easier way. For that, we have to transform our variate. This chi-square variate and its functional form are too much difficult to for us to integrate. And here the most complex part is this chi-square by 2. So we are going to let chi-square divided by 2 is equal to z, and chi-square is equal to 2z. And now we wanted to transform into a new variate called z, so we will differentiate both sides with dz, d by dz, chi-square d by dz 2z. Okay, if you differentiate that, d chi-square divided by dz, here it will be 2z, so this is a 2, so it will be 2, so d chi-square shall equal to 2 dz. We found it. Okay, now from here what we can write, now we can write 2 n by 2 n by 2, 0 to infinity, and e to the power minus z because this part is z now. Chi-square is 2z, so 2z n by 2 plus r minus 1 and d chi-squared to dz. Okay, fair enough. So we will extract this part now. 2 n by 2 n by 2 0 to infinity e to the power minus z 2 to the power n by 2 plus r minus 1 z to the power n by 2 plus r minus 1 to dz. Okay, now this part is constant, this one is constant, taking them out. 2 to the power n by 2 plus r minus 1 into 2 to the power n by 2 gamma n by 2 0 to infinity e to the power minus z. Okay, it's fair enough. Z to the power n by 2 plus r minus 1 dz. Okay, now recall a formula here. 0 to infinity 0 to infinity e to the power minus ax x to the power n minus 1 is nothing but gamma n divided by a to the power n. Here a is 1, so we can write a few lines. 2 more n by 2 plus r minus 1. This 2 has a power 1, so this power will be add up here. 2 to the power n by 2 gamma n by 2 and 0 to infinity. So now we will allow me to write this one. This is our n for here in this case, n by 2 plus r, and 1 to the power n by 2 plus r. Okay, now what we can write from here, so you can see that this one will be cancelled, and this one, if it is taking to the above, that will be minus. So this minus and this one will be cancelled, so we will leave with 2 to the power r only, and at the denominator we will have n by 2 gamma n by 2 and this part n by 2 plus r. And you know what is this? Yes, this whole thing is the earth raw moment. Now from this raw moment we will calculate our mean. So we found our raw moment, now we will find mean. Mean is defined as and denoted first of all mu1 prime is equal to expectation of chi-square only. You can write it like this one, but now for r here it is 1, so we can write it, so you can write it 1, so you can write it 2 to the power 1 gamma n by 2 n by 2 plus 1. You can write it like this one. Now you will have 2 gamma n by 2, and if you extract this one you will find n by 2 gamma n by 2, and this n by 2, this n by 2 will be cancelled, so you will live with sorry, here is n by 2 not gamma n by 2, so we cannot cancel it like this one. This 2 will cancel this one, so this one will be cancelled by this one, so we will live with only n. For more clear understanding, again, if you see this line, we have 2 n by 2 and we have n by 2 and we have n by 2, so this one will be cancelled, this will cancel, we live with this n only. Okay, so we found our mean. mu1 prime is n, which is mean. Now it's a task for us to find the variance. So variance will be, for finding the variance, the variance formula defined as mu2 is equal to mu2 prime minus mu1 prime all to the power square. We had this mu1 prime, but we don't have mu2 prime. So first we have to find mu2 prime. What is mu2 prime? Mu2 prime is defined as like this one, 2 to the power 2 n by 2 n by 2 plus 2. Okay, and it is 4. 2 square is 4 n by 2, and if you write this one, you can write this one like n by 2 plus 1 plus 1, right? So 4 gamma n by 2, you can write it like this: n by 2 plus 1 gamma n by 2 plus 1. So 4 n by 2, so again n by 2 plus 1, you can write this one: n by 2 n by 2. Okay, so here this one will be cancelled, so we will live with and this 2, where with 2, so we will have 2n n by 2 plus 1. So can we shut up this one a few more line? Yes, we can do. If we conduct here 2n plus 2 into 2n, so this 2 will be cancelled, n into n plus 2. This is mu2 prime. Now there is our main part, and it is mu2, which is the variance, mu2 prime minus mu1 square. That is not prime. Yes, it's prime. mu1 prime, mu2 prime. Okay, now put the values. First of all, this one, n into n plus 2 minus, and the mean is our n, so it will be n square. So n square plus 2n minus n square. This n square will be cancelled, so we are leaving 2n, and this 2n is nothing but the variance. Thank you very much.